Hi there and welcome to Mr. Arnold's Maths. In this video I'm going to work through the AQA Unit 2 Foundation paper for June 2011. Right, question 1. So 1A says, which two of the numbers add up to 29? We have a list of numbers and we want to find two numbers that add up to 29. I'll always suggest that you look at the last digit and that should give you some idea of what you need to use. We've got to find two digits that add up to 29. Well, if you look closely, 14 and 15, the 4 and the 5 gives me the 9 and 1 and 1 gives me 2. So 14 plus 15 gives us 29. And there is your first mark, 14 and 15. Okay, 1b, we're looking for a number in this list that is 12 less than one of the other numbers. Well, that certainly can't be 12 less than one of the numbers. Neither can that. Neither can that. Can 35 be less than 12? Or 12 less than any of these numbers? Nope, that doesn't work. 34, is 34 less than any of these? Nope, that doesn't work. 31, if you look closely, 31 is 12 less than 43. So 43 take away 12 is 31. So our answer must be 31. Right, 1C. Which number is half of one of the numbers? So again, looking through this list, I've got to find a number that's half of one of the others. Well, that certainly can't be half of one of the other numbers. Neither can that, neither can that, neither can that, neither can that, neither can that. What about 17? Could 17 be half of any of these? Let's just check. What's 17 times 2? 17 times 2 is 34. Therefore, 17 is half of one of the other numbers. So there's your mark. Which number is 3 times one of the other numbers? So, which number could be 3 times one of the other numbers? Let's look closely at these. 14. What's 14 times 3? Let's just have a look at 14 times 3. 14 times 3. Well, that gives us 42. 14 times 3 is 42. That means that 42 is 3 times one of the other numbers. So that works for us. That's our mark. And which number is a square number? Something everyone should know. You got to know your square numbers. Analyzing our list, not square, not square, not square, not square, not square. Keep going and you'll hopefully find out that 49 is a square number because 7 times 7 is 49. So 49 is your square number there. Right, question 2. We've got a grid and A and B are plotted on the grid and we want to find the coordinates of A. Nice and easy. Always remember along the corridor, up and down the stairs, and the point A is 2, 5. Nice easy mark there. Next question. Again, we have our grid and we're asked to plot a point 6, 1 on the grid. So remember, always go along your corridor first. That's 6 and go up as far as 1 and plot the point C. So that's our next mark. ABCD is a square. We've got to find the coordinates of D. Well, hopefully you can see that this is 1, 2, 3, 4 in height and 1, 2, 3, 4 in length. That means it's got to be 4 high here, which means that's our point D. And the coordinates of D are 6, 5, 6, 5. Write down the coordinates of the center of the square. Now what I told my students to do was actually, if you draw two straight lines, I'm going to try and do a freehand here. Draw two straight lines through your square. That will find the center of it, just in case you're unsure. So through two straight lines, you'll see that the center of your square is there. So it's 4, 3. 4, 3. Next question. Hannah has a box of chocolates and she gives half of the chocolates to Alex, and then Alex eats 5 of them and has 9 left. How many chocolates were in the box at the start? Right, well, if Alex had 5, or he ate 5 and then had 9 left, how many did Alex have? Well, he must have had 9 plus 5. So he had 14 chocolates. And Hannah had given half of the chocolates to him. So that means in total there must have been double the amount that Alex had. 14 times 2 is 28, and there are your 2 marks. Right, we're given 3 numbers and we're asked to complete these statements. It says 20 is the odd one out because it is the only even number. How could 21 be the odd one out? Well, one of the reasons would be that 21 is the only one in the 3 times table. Let me just erase that. 21 is the only one in the 3 times table. The only one in the 3 times table. Is there any reasons that 21 could be odd? I'm sure there are many, but that for me was the easiest one to spot. Why could 21 or 25 be the odd one out? Well, one of the reasons certainly is 25 is the only square number. So because it's the only square number. Another reason which I spotted was it's the only, so I'm going to put it here, it's the only factor of 50. So it's the only one that's a factor of 50 in this list. There are probably more. These for me were the easiest ones to spot. Right, question 5. We got 3 different whole numbers and they add up to 31. The first number is a multiple of 3, second is a multiple of 4, and the third is a multiple of 5. And we're asked to work out what the numbers could be. What I told my students to do was write out the 3, 4, and 5 times table and work from that. So 3, 6, 9, 12, 15, 18, 21, 24, and etc. etc. goes on. 4 times table, 4, 8, 12, 16, 20, 24, 28, and on and on. 5 times table, 5, 10, 15, 20, 25, 30, and on and on and on. Now let's try and pick out 3 numbers that add up to 31. So remember, the target number here is 31. Okay, so once you've had your 3 times table or your times tables written out for each number, then it's a case of picking 3 numbers, one from each list, that adds up to 31. Now there's lots of different answers for this. I'm just going to give you 3. If you look closely, 9, 12, and 10 will add up to 31. So you could have 9, 10, and 12. They add up to 31. You could also have 3, 8, and 20. 3 and 8 is 11. 11 and 20 is also 31. And another one I found was 12, 4, and 15. 12 and 4 is 16, 16 and 15 is also 31. So there's 3 different answers you could have had for that question. I'm pretty sure there's more. Right, moving on. We've got an estate agent advertising 4 houses. Each house has a different price, and we're asked which house is the cheapest. So looking closely at these numbers, let's do some elimination here. 132500. Right, well, that's certainly more expensive than these two, so I'm going to write both of these off because they've got 132,000. Now, which is cheaper out of this? House D. House D is the cheapest there. So, House D. Okay, which one is the most expensive? Well, it's got to be one of this or this. And looking closely, House A has the biggest price because 132,500 is bigger than 132,400. So House A. Moving on. We're asked for the difference in price between the cheapest and most expensive houses. Now, careful here. You got to remember that the cheapest house is the number we're going to take away from the expensive house. So the expensive house is house A, which is 132,500, and we're going to take away house D, which is 131,750. I'm actually going to do this problem twice because there's two different methods of subtraction that we can do. 0 take away 0 is 0. 0 take away 5 we cannot do, so I'm going to borrow 1 from this guy and put it on here. 10 take away 5 is 5. 4 take away 7 we cannot do, so I'm going to borrow 1 from this guy and bring it over here. 14 take away 7 is 7. 1 take away 1 is 0. 3 take away 3 is 0. And 1 take away 1 is 0. So 750. And just for those of you in my class that have seen this method, 132,500 take away 131,750. Slightly different method, how I learned it in Ireland. 0 take away 0 is 0. 0 take away 5 cannot do, so I'm going to borrow 1. 10 take away 5 is 5, but because I borrowed 1, I'm going to pay it back here. Now, 5 take away 8 cannot do, so borrow 1. 15 take away 8 is 7, and I pay it back here. And then you get 2 take away 2 is 0, 3 take away 3 is 0, 1 take away 1 is 0. Same answer. Last one, 7D. Jack buys house C and he pays a 10% deposit, and we're asked for what 10% is of 132,400. To work out 10%, you simply divide by 10. So we're going to do 132,400, and I'm going to divide that by 10. 10 fits into ones, it doesn't go into 1, so carry it over. 10 into 13 goes once, carry 3. 10 into 32 goes 3, carry 2. 10 into 24 goes 2, carry 4. 10 into 40 goes 4 times, and 10 into 0 goes 0 times. So we get 1, 3, 2, 4, 0. If you're really, really good at maths, you could have noticed that you can just simply just knock off that 0 there, and that will give you the correct answer. Moving on. Right, we're looking for the square root of 121. Square root means what number multiplied by itself will give you 121. Well, hopefully you all know that 10 times 10 is 100. So the square root of 100 would be 10. Right? 100 is smaller than 121, which means my answer's got to be bigger than 10. So let's try 11 times 11. 11 times 11, sure enough, is 121. Therefore, the square root of 121 must be 11. 3/5 of 45, I'm going to divide by the denominator and multiply by the numerator. So I'm going to do 45 divided by 5. 5 goes into 45 9 times, and then I'm going to do 9 times 3 to get 27. 27 is your answer. Moving swiftly on, 8% of 150. Well, it's always good to find 1%, okay? Just remember that 150 would represent 100%. That's the total amount. So work out 1% by dividing by 100. 150 divided by 100 is 1.5. That means 8% must be 8 times 1.5. So let's do 8 times 1.5. 8 times 5 is 40. Put down the 0, your decimal point. Carry 4. 8 times 1 is 8. 8 and 4 is 12. 12.0, or simply 12. Moving on. Show clearly that the value of 17 take away 5 divided by 2 plus 4 is 18.5. Now, what they're testing here is bid mass, or bod mass for those of you that have learned it that way. Bid mass. Brackets, indices, division, multiplication, addition, and subtraction. So our order of operations. Some of you might have learned brackets, order, which is indices, division, multiplication, addition, subtraction. Same. Right, so using this, we have to recognize that we've got to do the division before we do any addition or subtraction. So it's going to be 17 take away, what's 5 divided by 2? Well, it's 2.5. And then I'm going to add 4 to my answer. 17 take away 2.5 is 14 and 14.5 plus 4 gives us the 18.5 that we were looking for, which is the same as 18 and a half. Right, we need to find one pair of brackets, or put one pair of brackets in here to make the statement correct. So we're looking for an answer of 10. Right, let's just check. If I put brackets here, will it work? 17 take away 5 would be 12, so we'd end up with 12 here. So it would be 12 divided by 2 plus 4. Does that in fact equal 10? 12 divided by 2 is 6. 6 and 4 is in fact 10, so we know we're correct. We have our brackets in the right place. If you didn't get it that time round, just rub it out and try it again. Use two pairs of brackets this time to make it correct. Okay, so I'm going to try some brackets here, and I'm going to try some brackets here. I've just had a wild guess. 12 take away, or 17 take away 5 is 12. That's going to be divided by, what's 2 plus 1? It's 3, and I'm going to multiply that by 4. And is that in fact equal to 16? So, remember, division comes before multiplication. 12 divided by 3 is 4. Is 4 times 4 16? Well, yes. So we got our brackets in the right place. Lucky guesser. Alright, next one. A school shop can buy pens at £2.40, and they buy them in packs of 10, and they want to sell them for 50% profit, and they're hoping to raise a total of £72. We're asked to work out how many pens should the shop buy. Well, we know how much they're buying them for. It's £2.40. I want to know how much money they're going to sell them for. So if they sell them for 50% profit, what is 50% of this? 50% of 240 is half of it, so it's got to be £1.20. So that's 50%. That means their selling price, I'm going to call it SP, their selling price is what they bought them for plus the £1.20, which is in total £3.60. So I want to know how many pens would they have to sell at £3.60 to make 72. Right, this is a little bit tricky. I'm going to turn them both into pence. £3.60 is the same as 360 pence, and £72 is 7,200 pence. So I need to know how many times does this fit into this, and that will tell me how many packs. So it's a long division problem. So what we need to do is 7,200 divided by 360. Now straight off the bat, what we can do is divide both numbers by 10. If I divide that by 10, I can divide that by 10. It makes the problem slightly easier. How many times does 36 fit into 72? It goes in twice. How many times does 36 fit into 0? 0 times. So they're going to sell 20 packs. This question was especially sneaky because they put in this extra number here, which didn't seem to have any bearing at all on the calculation we needed to do. So be mindful of that. Right, next one, 11a. We got the first two terms of a sequence are given, and it tells us the term-to-term rule. So in other words, to get from one term to the next, we got to multiply by 3 and add 2. Let's just check if it works here. Well, 2 multiplied by 3 is 6. 6 add 2 is 8. So yeah, that works. And it asks us to work out the next two terms in the sequence. So I'm going to do 8 multiplied by 3 equals 24. 24 plus 2 equals 26. So our first number is 26. We'll put it up here as well. The next term in the sequence, we're going to do 26 multiplied by 3, which equals 78. And then we got to do 78 plus the 2 to get 80. Job done. Next one. It gives us the term-to-term rule of a different sequence, which is multiply by 2 and then add 4. and it gives us one of the terms in this sequence. So it tells us this term is 6. It asks us to work out the first term of the sequence. Slightly tricky. Now before I do that, I just want to work out the next term of the sequence. We didn't need to, but I'm going to do it anyway. 6 times 2 equals 12. 12 plus 4, 12 plus the 4 gives me 16. So we should be happy knowing that 16 is the first term. Now to demonstrate what we need to do to actually work out these terms, I'm going to use these two terms here. So we have to remember this number has been on a bit of a journey. He's been doubled and then 4 was added to it. And that's how we got to 16. I want to go backwards. So I got to do the journey in reverse. So remember, to begin with, we multiplied by 2 and then we added 4. If I was to go backwards, I should take away 4 and then divide by 2. Let's check if it works. 16 take away 4 equals 12. 12 divided by 2 equals 6. Bingo. So we know what we're doing now. So let's do that with the 6. 6 take away 4 equals 2, and 2 divided by 2 gives me 1. So that gives us that term. Well on our way now to getting the first term of the sequence. So I'm going to do 1 take away 4 gives me negative 3, and then negative 3 divided by 2. This tripped up a few people. Well, what would 3 divided by 2 be? It would be 1.5 or 1.5. That means minus 3 divided by 2 is minus 1.5. So the answer is minus 1.5. And if you finish the exam early, double check by going in the correct direction to see if you got it right. Because I have time here, I'm going to check it. Minus 1.5. So if that was indeed the first term, I should be able to work out this term by following this rule. So if I double minus 1.5, we get minus 3. And then if I add 4 onto that, I should get is 1. Right, if I do 1 times 2, we get 2. And then 2 plus 4 gives me the 6. So I know we've done it correct. So if you have the time in the exam, do check your answers as you go. This one, the electricity bill. Right, so it tells us that the first 200 units are charged at 24p. Everything else is charged at 15p. And this is the meter. Okay, you should ask your parents about how these meters work. It will give you a good insight into what this question was asking. I'll tell you about it now though. Basically, the way electricity meters work is they constantly keep a total of the number of units of electricity, and every month the old reading is taken away from the new reading to work out how much units you've worked or you've used over that month. So if I want to know how many units we've used in this month, we'll do 500 or 5,647 and take away 5,345, and that'll tell me how many units of electricity we used that month. 201. Okay, so or 203 should I say. Let me just tidy that up. So that month she used 302 units. Now we know that the first 200 are charged at 24p. So how many were charged at 15p? Well, I'm going to take away 200. So take away 200, we get 102. So I know that it's going to be 102 units multiplied by 15p plus the 200 units multiplied by 24p. Always remember, there's lots of different ways to do your long multiplication here. I'm going to choose to use the column method. 102 times 15. 5 times 2 is 0, carry 1. 5 times 1 is 5, put down the 0. 1 times 2 is 2, 0 and 1. Add them up, we get 0, 3, 5, 1. 1530. Now, just be careful. That was pence. So that means that's in pence, which means it must be £15.30. So that was the 102 units. We also have to do the other 200 units that she's used. So let's do that now. We're going to do 200 multiplied by 24, 48. Right, again, that's 4,800 pennies, which is £48. So to work out the total cost, because that's what we're asked for, the total cost of the number of units, it's going to be £48 plus the £15.30, and that gives us a grand total of £63.30. Right, so in this question it tells us that the number 57 can be written as a product of two prime numbers. It gives us an example, 57 is 3 times 19, and we're asked to find 3 more examples between 50 and 60 that can be written as a product of primes. Now, after some trial and error, I've discovered that 51 is equal to 3 times 17. Both 3 and 17 are prime numbers. 55 is 5 times 11. Both are prime numbers. And 58 can be written as 2 times 29. Now, I had to think about this question, and I found it quite tricky to actually come up with a good explanation or a quick way of doing this without going through trial and error. And I didn't want to sit here during the video and do all out the workings. So there's the solution to it. If somebody does have a better way of doing this question, please do let me know. I'd love to hear from you. Right, so the next question. Use approximations to estimate the value of 795.4 divided by 2.1 squared times 9.8, and it asks us to show our working. Now when you're asked to use approximations, you want to round, always round to one significant figure. One sig fig. Essentially you want to make these numbers as simple as possible. So 795.4 written really easily is close enough to 800, and I'm going to divide that by 2.1 squared. Well, I don't like that 2.1, so I'm going to write it as 2 squared, rounding to one significant figure, and I'm going to multiply that by 9.8, which is really around about 10. So that's approximately 800 divided by, well, that's 4 times 10, which is 40, and then simplifying your fraction, 4 into 80 goes 20 times. Okay, so in this question it tells us that we got red, blue and yellow counters, 3 times as many blue as yellow, and there's 43 counters in the bag to begin with. Some more red counters are added to the bag. It tells us then that we have 50 counters in the bag, but the number of reds have doubled, and we're asked to work out the number of yellow counters in the bag. Now I've put together a little model so that you can actually visualize what's going on. So we had a certain number of red counters, we had blue counters and yellow counters. There were 3 times as many blue as yellow, and in total at that time we had 43 counters in the bag. And then it tells us we've had some more reds added to the bag, and that there's now 50 counters. But it also tells us that the number of reds have doubled. So that's why I have 2 blocks here of the same size. So the number of reds has now doubled, and the number of counters in the bag has gone up to 50. That means that this red that has been added, this red block, must represent 7 blocks, or 7 counters. So that red was worth 7 counters. So that means if I take this red away, if I take this red block out beforehand, then we wouldn't have had 43 counters. I'm going to take away another 7. Taking away 7 leaves us with 36. That means the blue counters and the yellow counters gave us 36. But there was 3 times as many blue as yellow. That means total number of counters, so 1, 2, the 4 parts of counters, the 4 equal parts of counters must count to 36. That means the number of yellows would be 36 divided by 4, which will give us 9. So the yellow block on its own, number of yellow counters must be worth 9. So let's just write that down here. So originally we had 50 counters. That means the number of reds added was 9. Was equal, or sorry, not 7, was 9. No, it was 7, should I say. I'm confusing myself now. The number of red counters was 7, right? We had 43, now we have 50. That means the number of reds added was 7. If I take away another 7, the number of counters left after we take out all the reds must be equal to 43 take away 7 equals 36. And remember, 3 times as many blue as yellow. That means in total the 4 parts must be equal to 36. The 1 part must be equal to 9. Just a quick overview again of why did I have 4 parts? Well, for every 1 yellow counter we had 3 blue. So the ratio of yellow to blue was 1 to 3. Yellow to blue was 1 to 3. That means 4 parts were 36. 1 part must be 9. Quite a complicated answer, that one. Okay, so the next question involves a graph like this with 2 straight lines. Minutes of calls versus the cost, and it tells us that we've got 2 plans, A and B, and it gives us the details of plan A. It says the monthly charge is £20, you get 400 minutes of calls for free, and then for every minute after that you're charged 15p. So just looking at the graph here, you can see plan A, we're given the details about that. 400 minutes are absolutely free, so that's why the line does not start to rise. So that's why you have your fixed charge of £20 for 400 minutes, and then after that you start to get charged 15p a call. And that 15p is actually calculated from the gradient of the line. Right, the first question asks us, Ben usually makes 800 minutes of calls a month, and we're asked which plan should he choose and why. Well, if you go to the 800 minutes, and let's see what's going on at the 2 plans at 800 minutes. So I've drawn a straight line up from 800 minutes, and I want to see what's going on where it cuts the axis. So just zooming in there, hopefully you can clearly see that my straight line up cuts plan A before it cuts plan B. Now that's really important. It means for the 800 minutes that he usually makes, he's going to get charged roughly around £80. Whereas if he chose plan B, he's going to pay more than £80. So therefore we can say he should choose plan A simply because it's cheaper. So choose plan A because it's cheaper. And it tells us now that Sarah chose plan B, and we're asked how much she pays for every extra minute of calls. And if you remember what I said, the number of minutes per call, or sorry, the cost per call is calculated from the gradient of the line. So what we need is, we need 2 points on this line that we're going to calculate the gradient from. So 2 nice points. I'm liking that one there because it's clearly on 600 and we can see the £50. And I also like this one up here because it's 150 and 1,000. So pick 2 nice points. Oh, I've just noticed I've chosen a point that's not on the correct line. I should be choosing, say, this point here. This point here is nice because it's on 630. Okay, So remember, the gradient is the change in y, so uh, the rise over the step. The change in y divided by the change in x. The rise over the step, as I've described it to my class. And the rise is going to be, let me see, 150 take away 30. So the change in y divided by the change in x. The change in x is going to be 1000 take away 600. And that gives us, well, 150 take away 30 is 120. 1000 take away 600 is 400. So we got some fraction of a pound. Let's work it out. Cancel those out. We can divide top and bottom by 4. 4 into 12 goes 3 times. 4 into 40 goes 10. So we get charged 3/10 of a pound per call, which is 30 pence per minute, should I say. So she gets charged 30p per minute, and that's where you pick up your 3 marks. So use the gradient, work out the gradient. Okay, last question. So we're asked to solve this equation. Right, first and foremost, expand your brackets. If there's nothing you can do, if you feel you can't solve that equation, you should definitely be able to solve the expand the brackets and pick up at least 1 mark. So 5x plus 3 must be equal to 3 times x, which is 3x, plus 3 times 2, which is 6. Right, 5x plus 3 equals 3x plus 6. So taking away 3x from both sides, we get 2x plus 3 must be equal to 6. And then I'm going to take 3 away from both sides. We get 2x must be equal to 3. 6 take away 3 is 3. And dividing both sides by 2, we get x must be equal to 3 divided by 2 is 1.5. So that's your correct answer. And the final question of the paper, we're asked to work out the values of a and b. Now this can look a lot scarier than it really is. One thing everyone should be able to do is at least expand and simplify. So expand and simplify. It looks familiar. Right, so 2 times x is 2x. 2 times 16 is 32. Plus 4 times x is 4x. And 4 times negative 5 is minus 20. Right, tidying up. 2x and 4x is 6x. 32 take away 20 is 12. So we got 6x is 12. We want it in this form, which means if you look at this closely, I can factorize this. I can factor out the 6, and 6 multiplied by x plus 2 is this expression factorized fully. And if you look closely, a must be 6 and b must be 2. And that's it. AQA 2011 June exam done and dusted. Hope you enjoyed the video and best of luck in your exams in the future. I'll talk to you again sometime. Take it easy.